because I'm a student, you are a student. So it's a kind of a discussion. Okay? Fine. For this equation, bx equals to 1 and qx equals to e raised x. E raised x. So the integrating factor is, what was the integrating factor here? Ux equals to e raised e integration of bx dx. So we are told here, so the integrating factor is u into x equals to e integration of bx dx. So e integration of bx is 1. Actually, we are here. And then who can show us how we get this bx to be 1 here? Actually, after differentiating dy dx, you get how what actually what, yeah, bx dx. This means that this bx is here. So when you look at this one, it means that x is here. So bx, who can tell us how we get this bx to be 1? And then qx equals to e raised x. Because for the general solution, for the first order differential equation, we were told that y prime x plus bx y equals to q raised x. So this is q raised x. This is b raised x is yes
So what
very good.
is it
Yes.
not y dx?
Eh?
Is that one not y dx? So
It
that
is
when
y.
we differentiate y, we get 1.
When you differentiate y,
Yes.
so it means that we differentiate what to be 1. This y. Come up again.
Yeah. That is how I'm thinking.
Oh, yes, I'm seeing some who have raised their hands. Veli, Obuzena, and Kishira Murid. So Kishira, just keep going. Amos Yeruya. Yes, can you tell us something?
Okay, I think we have you say that the solution for this is it is ux equals to exponential functions of integral of px dx. So we say that px apogee is px equals to 1. So when we differentiate 1, we get dx. So that's how now exponential function of integral of dx comes.
Okay, so fine. Has everyone understood this point?
Yes.
Okay,
Yes.
Yeah.
we can proceed. We were here. So you this one whatever. So you integrate when you integrate dx will be x. So there will be e raised x. This is the integrating factor. Then we saw that the general solution of this one is y equals to 1 over ux, the integration of q raised into x u x dx. So let's move and see this one after getting the integrating factor to be e raised x. This implies that the general solution is this one, and then 1 over u raised x is 1 over e raised x. The creating the q of x here is q of x was the e raised x. And then u into x was e raised x here. Yeah, is it? And then dx. you find that q of x in the first equation was e raised x. And then after getting the integrating factor, which is u raised x, which is u into x, it is e raised x and then dx. Who can tell us which technique should we use to integrate e raised x into e raised x dx? Yes?
I think we are using substitution
think-
method.
Yes. Substitution
Amos.
method. Yes?
Yes.
Amos,
Yes.
can that thing not be? Can we square like e times e so that we can get e 2x, e raised to 2x,
E
e
raised
square 2 e square x. We square the e.
we square this e.
Yeah?
Times e to be
Yes.
e square.
So that we can get e x.
E square e
When the
e
bases are the same, you add the powers.
and the bases are the same. Are they? No.
Yes, you add only powers.
Here is the base.
When the
Oh,
base are the same, you
you
only
add
add
power.
powers so that you can say x plus x to be 2x. So it will be e 2x raised to 2x.
E2x.
Kitu kama hiyo.
Okay. Integrate after
E raised to 2x.
integrate now. E raised to 2x dx.
So it will be
Unaleta ngapi sasa?
unaleta 2 ikuje chini alafu unasema half.
No, you
When
remember
integrating
that
e raised to a constant x. Amos,
yes,
Chebocho,
I'm hearing you.
I'm saying when you are integrating e raised to constant x,
Yes.
you bring the constant into unaleta the chini alafu the constant inabaki tuko raised to constant huko. Sasa unaleta 2 ikuje chini ndio ikuwe e 2x e raised to 2x all over 2.
Okay, which is the same as half e raised to 2x.
Yeah, kitu kama hiyo sasa.
And then plus c.
Yeah, it's not okay.
And then plus c because it was something like it's not particular, it's general. So this one over e raised x is the same as e raised negative x. So half e raised x. Now I'm floating here. You read for yourself there. So you read for yourself there because we are or who can explain to us what is taking place there? Yeah.
I think
Yes.
Yes.
yeah, I think what is taking
It
place.
is like this. Okay.
Okay, can I explain?
Yes.
Do you understand?
Yes. Explain.
Okay, I think what is taking place, e raised to negative x.
Yes.
Now after integrating on the other side, we get half e raised to 2x squared. So this is the same as 1 over x. So ex and 1x at the x square cancel out. So when it cancel out, we remain with 1 ex, not ex square again. Are you getting it? So then now, because this one we were multiplying a factor of e with
I opened the browser using e negative.
so since we are multiplying the e factor with you multiply o plus constant. So you will end up having now half e raised to x plus c raised to e negative x.
You open bracket.
When you come the bases are the same,
Between 1 plus 2
it plus 2 x, it opens plus 2x. Yeah.
So Hope everyone has got it. So this is the checkpoint one.
Yeah.
General solution of this one. You have to do this one. This is an assignment. We'll come to check on the next class. Let's proceed. An example one. The differential of the equation was given in standard form. For equations that are not written in standard form, you should first convert to standard form so that you can identify the functions of bx and qx. So in this one, we were given this one in standard form. So whenever you are not given in standard form, you have to first convert to the standard form so that you can identify bx and ux. Example 2, solving the linear differential equation. Find the general solution of x y prime minus 2y equals to 2x equals to x squared. Assume that x is greater than 0. Yes. What is the standard form of this one? Or because standard form was saying that y prime minus b raised to x y equals to q raised to x. So you can tell us the standard form of that one.
But for what? Relax.
I'm seeing this here. Begin by writing the equation in standard form. When you write this one in standard form, you divide by x. Yes.
Amos,
Yes.
continue.
Yeah. Divide by x everywhere. Okay. And then when you divide by x, it will be y prime minus, yeah, plus into minus is the same as minus, so it is plus into negative 2 all over x into y minus x square all over x will be
X.
x. See there?
Yes.
So the standard form now will be y prime plus p raised to x. This is how we should write now. So in this form, you can see that b raised to x is negative 2 all over x here. And then qx is what is x. So in this one, integrate bx dx equals to minus this one. This is dx. I'm trying to connect. My mind is loading.
I'm not here. B raised the x equals to this one, and then q of x is x. So, okay. You first find the integrating factor, is it? So, integrating factor here, you remember here, integrating factor, you are saying that u raised the x, u into x equals to e, integrate and then bx dx. That is you find the integrating factor actually. So here the integrating factor, you integrate dx dx to get the integrating factor. When you integrate dx dx, it will be dx was negative 2 all over x, which is the same as negative of integration of 2 over x dx. So 2 of x is the same as negative 2 ln x, which is the same as negative ln x square, which simplifies the integrating factor. Yeah, which implies that integrating factor is e raised to ln x square, isn't it? We were trying to get the integrating factor here. After getting that one, we say 1 all over this one, 1 all over u, which is 1 all over e raised to ln x square is the same as x square. E ln x square is the same as x square.
Yes.
E raised to ln x square is the same as x square. So this implies that the general solution is, you remember that the general solution was y equals to 1 all over ux, the creation of qx, u into x dx. So qx was x, yeah. And then this is the integrating factor, which is 1 all over x square, and then the x. So you integrate this one, and then u is 1 over 1 all over x square, because this one is a u substitute. So 1 all over 1 over x square will be x square. So this one times this one is the same as 1 all over x. Yeah. Then the x. Is it true? Is it true?
Yeah, it is true.
Okay. X square, when you integrate it, and be ln x plus c. And then x square, this one, into ln x plus c is the general solution. Hope everyone have understood that.
Yeah, not bad.
So we can have maybe if we can proceed from there, we can have like 3 ln x plus x cx square.
Or you open the bracket
Yes.
to be x square ln x plus cx square.
So yeah, so it will be 3 ln x plus cx square.
Where is 3 coming from?
Okay, I'm saying 3 is coming from
Yeah.
x cube is the same as 3 ln of x.
You just apply the laws of the laws of
Of
logarithms.
yeah.
Okay,
Yes,
okay. So, and it will be the same as this one. When we leave this way, it will also be okay. This is the checkpoint.
Yes.
This is the checkpoint too. You have to do this one. You first, what we were talking, you first find the, you first write in the standard form so that you can identify P, X, and QX. Then after writing that one, after writing in standard form, you find the integrating factor. The integrating factor is 1 all over u raised x. And to get u raised x, you say raised e raised to integration of b x dx. Is it? Yes. To get that u x. And then after getting that one, you say 1 all over u x to get the integrating factor. And then say that after getting the integrating factor, you come and substitute in the general solution, which is 1 all over u x times integration of dx, this one, 1 all over ux, integration of qx, ux, and then dx. And then get this one, and you will get the general solution from there. Hope everyone have understood that one. Yes?
Yes, I understood.
Guidelines for solving linear differential equations. These are the guidelines now for you to solve the linear differential equation. Write the equation in standard form. Yeah, you write them into standard form and then find the integrated factor. Then evaluate the integral below to find the general solution. Is it? There are three steps you have to follow when solving a linear differential equation. Okay, this is the application. Those are the applications that hope everyone will look. Can we go through those or we leave for the day? We oh yeah, oh yeah. Tell me this
Oh
slide.
yeah, graph issue. Oh yeah.
Can we leave from there for only leave there for the day or we just continue with the applications?
I think we attempt one application, then we leave from there.
Okay, the one we
We can go with that day.
no, Jebujuk, you have to be you have to your committee is not responding to whatever we are doing. So kindly bear with some of people want to read. Sorry, you understand? Hello, Adi. Yeah, example 3 here. You mean? Then application of this one, intravenous feeding. This is one of the application of the first order differential equations. Yeah, glucose is added intravenously to the bloodstream at the rate of Q units per minute. And the body removes glucose from the bloodstream at the rate proportional to the amount present. Assume that A is the amount of glucose in the bloodstream at time t, and that the rate of change of the amount of glucose is dA over dt. Is dA over dt equals to Q minus okay. Where guys constant, find the general solution of the differential equation. This one now dA all over dt equals to Q minus K A. First of all, standard form, write this one in standard form. This linear is dA all over dt plus Ka equals to you move this one to the other side and then you do that way, which implies that bt equals to k. Yeah, bt equals to k and then qt equals to q. So our b of t is here. Remember, b of t is the same as is b x, but this one is t time. The time now you are differentiating this one with respect to t. So p of t is time, but for the first case it was x. So p of t is k, and then b q of t is q, small q. So the integrating factor is, for you to get the integrating factor, you say 1 all over u raised u into t, and to get u into t, you say p integrate p of t dt, and our p of t was k. So e integration of k dt will be e raised kt. So it will be is the creating factor. Okay, the creating factor. Okay, this is the integrating factor. So, and the general solution is 1 all over ut, and then integrate qt ut, and qt was small q, and then ut we have got to be e kt and then dt, and 1 all over this one will be e minus kt. And then e minus you integrate this one to get what? You remember that you get whenever there is constant here, you say q e kt all over k plus c, and then 1 all over e kt is the same as e raised to negative kt, which is the same as q all over k plus, when you open the bracket, will be this one times this one is, this one will go, and then you get this one, negative and positive cancel, and then you say this one, these things, this whole of these things go, and you remain with this one, q all over k plus c into c e raised to negative. This is now the general solution. Has everyone understood? Okay.
Yes, understood.
Yes, understood.
Okay.
Yeah, but we can go to the day.
Before we leave or before we end there, you attempt this one at your own time. A equals to q all over k plus, use this one, the general solution, this one, this is the general solution. For example, 3, for example, to find the particular solution. You remember that particular solution is different from general solution. Particular is when you are given the limits determined to the solution determined by initial condition a equals to 0 when t equals to 0. Assume k is 0.05 and q is this one. Hope everyone will replace it. And then you cut this c. After cutting this c, you come and say a equals to q all over k plus whatever you get from this c, and then e raised to negative k t. Yes, thank you for cooperating. So we are in small number, so let's stop from there. We can call it a day. Aaron Kiri Kimngeno, you can pray for us. Or who is volunteer to pray? Volunteer to pray. Volunteer to pray. Volunteer to pray. Yes, Amos.
Let us pray. So, most gracious Father, we say thank you this particular morning, Father, as we have discussed, Father. What you have discussed, let it stick in our mind until we meet in our next class. For I pray that those who have attended this class, may they leave when they have grasped something. For I pray this prayer, believe and trust in Jesus' holy name. Amen.
Thank you and God bless you.
Sunday morning.
Thanks.